everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please read it, try it yourself, come back, and we will hopefully offer different ways how to do it and do it together. Okay, the table partially summarizes the percent of residents in different counties who participate in performing arts lessons at least once a month. The percentages have the range have a range of 12.9%. What could be the percentage of County G residents who participate in the performing arts at least once a month? Ignore the percent symbol when entering your answer. Okay, fine. So the range has to be 12.9. So first you have to know the definition of range given a bunch of numbers. The range is the difference between the highest and the lowest. So, I don't know, look at the lowest. And they want a range of 12.9. So 4.7 plus 12.9 would make 4, 5, 6, 7, 17.6. So the difference between 17.6 and 4.7 is 12.9. Okay? Difference. So wouldn't difference. So that would mean that G would have to be 17.6. Right? Is it that straightforward conceptually?
Well, I don't see the verbal statement of the problem. I just see the table, and
What?
And I'm skeptical about.
You don't wait. What type of screen sharing are you doing? You don't see the question?
Nope.
Okay.
It's too big.
Here. Stop screen share for me. What is this? Now, are you seeing it? How could you not see it? I don't understand. You don't see it? What do you see?
I see a table of counties and percentages.
Yeah.
Counties A through G.
Right.
And some percentages, and the bottom percentage is a question mark.
Oh, I don't know what's going on with your Zoom, but we have to move on. So, okay, all they're asking, trust me, all they're asking is what does G have to be so that the range of these numbers is 12.9. That's what's being asked.
So they say the range of, okay, repeat what they said the range is.
12.9.
No, I know. What is their definition of range?
They say the percentages have a range of 12.9%. Therefore, what does G have to be? That is the question.
Yeah. Okay.
Okay? It's not that hard of a question conceptually, but you have to know what the meaning of range is. If you don't know what the definition of range is, you can't do the problem.
All right, so if you add 12.9 to 4.7.
Yeah, that's what I just did. So Seth doesn't see anything. Seth has some sort of problem today, which fine.
I want to do it myself.
Fine.
To 4.7.
Totally overriding me.
9 and 7 make 16. 4, we have 17.6.
Yeah, okay, we all agree. So let's just.
And so you're supposed to fill in 17.6 here.
That's right.
17.6.
Okay, so again, there's really not a lot of ways to do this problem, but you must know what range is. Range is the difference between the highest number and the lowest number given a bunch of numbers.
Okay. All right.
That's it.
All right.
Here we go. Okay, so let's now Seth really can't see anything, right? Like you really.
I can see the top half of the problem.
Okay, you and I are going to have to talk about this because Zoom changed every time a computer program changes, it never works. Okay.
It works
So,
partially.
partially, right. So, since we're given all the ranges, the percent uh, of G resonance most likely has something to do with the range. Okay, fine. Based on the table, uh, count E as the highest value. The lows are low at the 4.7. Okay, so they
Yeah.
basically say this. Yeah, so the range has to be
Yeah. Do
right.
they say that County G has the largest?
No, they say they're comparing E and F first to see whether the range is 12.9. It isn't. They're first comparing E and F. The highest range that's on the table and the lowest range that's on the table, and they say that's only 12 point. That's only 12 point. What
The
is that?
highest data value.
Yeah, the highest data value. Yes, I'm sorry.
Okay.
Yes, the highest data value is 12.3. No,
So the highest
17.3.
the highest data value except for G, the
Right,
unknown,
exactly. That's exactly right.
is
So they
E's. The lowest data value is F, and
right,
so the strategy is to calculate the range of the numbers that are given,
right,
right? And if that range were equal to the range they tell you, then there's no way to figure out what G is.
no, G can be anything.
G could be anything,
Yeah, in within that range.
whose difference from any of the none of the numbers is less than
Right,
the
right,
range that they give,
right.
and
So
any value of G that meets that criteria is possible.
right, but
But they cooked up the problem. They cooked up the problem so they gave you a range that was bigger than the range among the numbers they give you.
right,
And so G must be one of the percentages that's on the boundary of the range. And then you figure that out
right.
by modifying the yeah well, since we don't have negative values, the bottom number in the data table is the smallest number, and the range is the smallest number. The largest number is the unknown number, and that is the smallest number plus the range they tell you is the range. All right.
Seth, with his PhD in math, makes things sound more complicated than they are. Okay. Well, the other thing, I don't know what they're doing here. They're wasting everyone's time, as far as I'm concerned, on these first few steps. Just get the number, and if the number here, if they get, just figure out what the what this number has to be. Adding 4.7 to
Yeah.
12.9, and if this number here is higher than this number here, then that's the answer. You don't
Yeah.
have to do this
Okay.
this pre-investigation.
Yeah.
Okay, so today is Throwback Thursday, which means we go back to an SAT question that was given maybe, I don't know, in the early 2000s or late 1990s from the official SAT book, and we give a sense as to the different types of questions that were asked back then. So here we are with our Throwback Thursday question. I looked at it. Of course, I didn't do it yet. That's cheating. But I can tell immediately that personally, we're giving this one to Seth because Seth is a PhD in math, and his expertise was combinatorics, which is basically counting things. I do not have that knowledge. I have a PhD in mechanical engineering. This is a question made for Seth. So, Seth, hopefully you could do this thing and you can explain it to everyone, including me, how to do this problem without just brute force or guessing. Okay, so as you could see, a question like this, you would probably never, ever see in
Okay.
a post 2016 test. Go
All
for
right.
it, Seth. Let's feed
Okay.
Seth.
Let me see the question.
Are you kidding me? You don't see it?
No, I don't. I don't kid you about anything.
What are we?
I do not see it.
Oh my goodness. I'm sure. Okay, fine. Let's stop the share. Fine. Stop the share. And now we screen share again. Now, here we go. Ready? There.
The
Now.
screen share didn't change. I'm going to.
Now do you see it?
Nothing changed. Nope. Something is
very wrong with
off.
your Zoom.
Yeah.
Yeah. Do you
Yeah.
want to just
They don't have a reset.
why don't you end the meet? Why don't you leave the meeting and come back? Or should I
Okay.
stop?
Will do. Will do.
Yeah, leave the meeting and come back. And I'm really sorry about this, everyone. Okay, so what's going on here? What is the greatest number of 4x4 squares that can be traced out along the existing line segments of the 8x8 checkerboard? So, okay, Seth's coming back. Let's hope this works. Okay, we're letting him back in.
Okay, I'm back in.
Hello. Okay, let's try the screen share.
I see a different content. It's a checkerboard was what I see.
Ah, you see the checkerboard?
But I don't see any question.
How could you not? Wait, how's that possible? It's the Zeitboard thing. How's this possible? You see the checkerboard, but you don't see the question underneath it.
Don't ask me why. I didn't write the software.
What is going on? You don't see the checkerboard?
Okay. You made it smaller.
Yeah.
And I saw the text briefly, and then you shifted it down.
How about that?
The text is, shifted so that it goes up and to the left. Okay, good. I see it.
Now, can I make it a little bit bigger?
Now. Okay, good. I see. Okay. You can make it bigger.
Tell me when you can't see it anymore.
Okay. Good. It's perfect.
Kurt, okay, good. Okay, so Seth, PhD in math, combinatorics. This is your question. How do you do this thing?
Okay. No, I don't ask how I'm going to do it first. I ask, what does it ask for first?
I'm asking you how you're going to do it.
Well, I didn't read it.
Fine, go ahead.
So I don't know.
Okay, go ahead.
Go ahead. Okay, what is the greatest number of 4x4 squares that can be traced out along the existing line segments of the 8x8 checkerboard above? Okay, so I assume that the deal is, let's see, I'll use red.
Yep.
I shall use color red. And I'll use that one of the 4x4 squares for which we want to figure out the greatest number of which can be drawn. I will draw the first one, and I think that is this guy. Right?
Agreed. Absolutely.
Right. Great. Now, in another color, I'm going to draw another guy.
Good.
That might be counted.
Yeah.
Right? Okay. All right, so far it's 2.
Right.
And let's do a yellow one. 4x4. 1, 2, 3, 4. 1, 2, 3, 4, right?
Got it.
All right, so far I got 3.
Yeah.
Well, so let's see. So now I think I know. So now what I'm going to do is therefore erase everything.
Okay.
And see if I can understand this systematically.
Good.
To start drawing one of these squares, I have to pick a upper left-hand corner, right? Possible upper left-hand corner. And it has to be an upper left-hand corner of such a thing, so that it's, in order for it to be the left-hand corner of a 4x4 square, if I go to the right 4 squares and I go down 4 squares, it has to still be in the rectangle.
Right.
So which corners have the property that if I go to the right by 4 and go down by 4, I'm still in the rectangle? Well, what about this point, this corner? No.
Failure.
What about this one? I go to the right, I'm still in, but if I go down, no.
Right.
So my geometric intuition tells me that Okay, I'm going to put it in red. That this is a critical square,
Right.
right?
Right.
If I'm anywhere strictly, if I'm anywhere strictly to the right, if I try to put a upper corner of my new 4x4 square, anywhere to the right of this red dot, it's
Yeah.
a no-no.
Well,
And
wait.
similarly, if I'm
Wait.
going to put my corner square anywhere below the red dot, it's also a no-no. So therefore, the only corners that I could make is the only points where I could make that I could take as an upper left corner of a 4x4 square that remains that is actually within the given checkerboard. I just do it by brute force, fill them in. And how many are there? I have 1, 2, 3, 4, 5, and 5. I got 5 choices for which row to pick, and 5 choices for each column. Sorry, 5. 5 times 5 equals 25, and I picked 25 as the answer.
So that was I guess, see how I blacked it out. That was the answer given. But let me ask this. I have a very, very important question. Okay. What about this square starting down here? 1, 2, 3, 4. 1, 2, 3, 4.
Every 4x4 square.
Okay, now what about
every 4x4 square?
Yeah.
Has 4 different corners, and the different corners have 4 specific special properties.
Got it.
Upper left.
Got it.
Lower right.
Got it.
Upper right. Lower left.
Got it. Very smart.
So I am characterizing a 4x4 square by which point is its
right,
not arbitrary corner like you did, but upper left corner.
Very smart. This is why you
yes, that's why I got a PhD for thinking that way, and also working very hard and doing a lot more thinking and spending a lot of time and patience and frustration.
And look, it pays off because you can do this question pretty well and pretty efficiently. Very good, Seth. So just to be sure, let's check the answer according to the official SAT book. This is section 1. Just takes a second to look for the answer. Section 1. They don't even give explanations back in these days. The SAT book just told you what the answer was. They've let you fend for yourself. Section 1, number 25. We're happy to be the last section. D. Congratulations, Seth. You got it right. Or at least you got what the SAT people said also.
Okay, so what lessons have you learned about approaching a problem like this?
Well, first of all, the lesson I already knew is you first start playing with it, right? What first Seth did is he started drawing different boxes just to get a sense of the problem. That is absolutely critical. Seth did that. That's what I would have done too.
Well, that's the lesson. That's the lesson from this problem. But the first principle for how to approach it is read the question.
Yeah.
And ask what are they asking for. Right. And then play with not the count of what they're asking for, but play with 1 or 2 or 3 examples of the thing they are counting, the thing that they are asking you to count.
Yeah. Yeah.
So playing with it doesn't mean immediately trying to pick all the possible ones, but to pick the first one and the second one to get a feeling for what it is what does it mean to pick a 4 by 4 square that can be traced out along the existing line segments of the 8 by 8 the checkerboard shown above?
So, Seth, you probably can't see me writing.
No.
But I'm writing that once you do that, you have to ask yourself, what is the criteria for an acceptable square? And that's the key. That's where Seth came through. The criteria for an acceptable square is its left corner has to allow enough space to go 4 across and 4 down. That's the key. Once you realize that the criteria is that you have to have that point, that upper left, the upper left, I won't write it out, but the upper left has to be in a position where it can allow enough space to go both ways, then boom, then the problem just falls right out. So This is the critical thing to ask. But of course, see problems like these multiple times, and he's seen this approach of what is the criteria that you have to get to meet what you need, what you're being asked for, is the really overall overarching way of thinking. So when you see a problem that we can't possibly predict what it's going to be, try to ask yourself, you don't know if it's going to work, try to ask yourself, what's the criteria that needs to be met in order to get the condition, what's the criteria that needs to be met on what I'm working on. Once you realize that, then you just count the number of dots, count the number of possible corners, or count the number of
So what I did was figure out the region.
Yeah, right.
Where the corners are excluded.
Right.
Figure out the region where the corners are excluded.
Yeah.
And then figure out the number of corners.
Yeah.
In the region that's outside of that region.
If you wanted to make your life harder, you could have done the lower left, the upper right, the lower right. You could even done the center, couldn't you? If center is more complicated.
Oh yeah, you could do the center. Yeah,
you could have done the center also.
Yeah. Anyway, yeah.
Wow, but you got it. Yeah. Boy, okay. Anyway, you're never going to see a problem like this. It doesn't look. This is not part of the new test, the post 2016 test, and it's not likely to be part of the digital test either. So who are we? Seth, you're a PhD in math from MIT, a professor emeritus in computer science at SUNY Albany for many years. I'm Seth's brother, Joel. I'm PhD in mechanical engineering. I take a more practical approach, and I never saw problems like these in my life. And we are here to hopefully show you how to do math SAT questions, and also how to study for the math SAT, which we suggest going to Khan Academy and taking either one of their courses, the non-digital or the digital classes. We try to do this once a day, and please give us comments on our YouTube videos. They're very helpful to know how we're doing. Please like us, dislike us, and please email us your SAT math questions at satmathquestionoftheday@gmail.com. That's it. We're done?
We're done.
Okay, everyone. Have a great day.